Welcome to MRU E-Learning powered by Malla Reddy University. Today my topic is implementation of compilers and code optimization. Myself Dr. K. Raishuru, Associate Professor, AML Department, Malla Reddy University, Hyderabad. Today let's discuss about the compilers. A compiler is a translator that converts a high-level language instructions written by the users into the machine level language that understandable to the compiler, that understandable to the machines or CPU. High level language is written by a developer and machine language can be understood by the processor. Compiler is used to show the error messages to the programmers. The main purpose of the compilers is to change the code written in one language without changing the meaning of the program. Let us see the block diagram of the compilers. Compilers take the source program as the input and gives the object program as the output. The object programs can be taken as a input by the assembler and it converts a pure machine level language code that we can call as a target program. Target program can be understandable to the processor, zeros and ones, that is a machine level language. To implement the compilers, the basic thing we need is the automata. Automaton, in plural automatons or automata, is a self-operating device. This automata theory lies in the computer science and discrete mathematics. The term automata derived from the Greek word automata, which means the self-making. It means it automatically processes the specific works. So to run the compilers, automata theory is very important. Examples of automata machines are vending machines, traffic light systems, video games, compilers. As we discussed, a compiler translator converts the high level language into the machine level languages. Let us see the phases of the compiler, that means how the compilers are going to be implemented. Every instruction from the high level language which is written from the users or developers or programmers, that should be translated to the machine level language that can be understandable to the processor. So while translation, every instruction in the high level language can be passed through these phases. We can call them as the phases of the compilers. There are 6 phases of the compilers are there. First phase is the lexical analysis, syntax analysis, semantic analysis, intermediate code generation phase, code optimization phase, and next is the code generation phase. Here after code generation, assembly language code will be generated. As discussed earlier, assembly language code can be passed through the assemblers. First, high level language instructions from any C language or Python language or Java language that can be passed through the compilers. Compilers generates the assembly language code. Next, assemblers will take that assembly language code and loaders and linkers will add the necessary files to run the basic program in the computer, like .dll files, .lib files. Okay, these files are to be added by the loaders and linkers. Then pure relocatable machine language code will be generated here. So after the loader and linkers adding the DLLs and library files, absolute machine code will be generated. Which one? Absolute machine code will be generated from the loaders and linkers. This absolute machine code will be understandable to the processors. This absolute machine code. After the loaders and linkers processing, absolute machine code will be generated. So this is all the completely machine oriented, like assemblers and loaders and linkers are completely machine dependent. So right now we will focus on the compilers. The main purpose of the compiler is converting the high level language instruction to the absolute machine codes. Okay, these are all will be there. Okay, right. Let us see the one by one the phases of the compiler. The first and foremost phase of the compiler is a lexical analyzer phase. The first phase of the compiler is lexical analysis. Lexical analyzer will scan the program from left to right. From left to right. Okay. Suppose for example, for I equal to 1, I is less than 10, I plus. Suppose the instruction is there. It reads the given instruction from left to right. First it reads the character F, and next it reads the character O, and next it reads the character O. Immediately it understands that it is a reserved word, and this reserved word will be saved as a token, or also official language we can call as a lexemes. In this stage, the compiler reads the source code character by character and breaks down into a series of tokens such as keywords and identifiers and operators. So these are known as the tokens, general word. Okay, these are the operators: assignment operator, semicolon is operator, less than is operator, one token, and this 10 is a string value, and this is an incrementer operator, is a one token. So it will generate the complete tokens from the given instruction. These tokens are passed on to the next stage of the compilation process. The next phase is the what? Syntax analysis phase. The second stage of the compiler is syntax analysis. In this stage, the compiler checks the syntax of the source code to ensure that the rules of the programming languages will be followed. So this syntax analysis purpose is to construct the parse trees, which are the hierarchical representation of the program structure. Suppose the given instruction is v equal to u plus at is the given instruction is there. It constructs the parse tree. Like assignment operator will be taken as a root node, and the first and foremost operation computed in this instruction is a into t. This will be first evaluated as a multiplication in the highest precedence. So first operation carried out is a star k operation will be carried out. Next, the result of the a multiplied with t is going to be added with the u. Okay, that is the result of this point will be added with the plus operator in the u. Okay, so this is one of the parse trees for the given simple expression. Okay, this is a simple expression. B assigns the u plus a into t. This is the first multiplication operation is going to be performed. So this syntax tree is a hierarchical structure how the expression is going to be evaluated. So it helps it generates a parse trees. Semantic analysis. In this phase, it checks the meaning of the source code to ensure that it makes sense. That means whether the language instruction is following the type equivalence rules or not. For example, let us take the assignment operator. Okay, we suppose take the v equal to u. Let us take. When you are performing the assignment operation, the compulsory right hand side value type definition should be equivalent to the left hand side type definition. This is known as a type equivalences. The data type value, the data type of the right hand side expression should be equivalent to the data type of the left hand side. Then only assignment operation will be works. So if any right hand side, if any operations are going to be performed, so suppose integer to float, float to double, double to float, such any conversions are there, that has to be performed, so that left hand side and right hand side type equivalences should be matched. So this is a task of the semantic analysis. Semantic analysis also known as the annotator. Next phases are, the first three phases are very important phases. So lexical analysis phase and syntax analysis phase and semantic analysis phase. These first three phases are known as the analysis phases. Analysis phases. These next three phases are known as the synthesis phases. Synthesis phases. These first three phases are completely language dependent. Language dependent, because every language having its own grammar rules. So according to the grammar rules, according to the production rules of the grammar, the syntax trees and parse trees can be varies. If you observe these analysis phases again, the first three phases, lexical analysis and syntax analysis and semantic analysis phases, these are language dependent but machine independent. Machine independent phases. Independent phases. Whereas coming to the synthesis phases, these are the language independent phases. Language independent phases, like intermediate code generation and code optimization phases and code generation phases. These are language independent phases, but these are machine dependent phases. Machine dependent phases, depending upon the hardware, depending upon the processor speeds, these phases will vary. Out of these all the phases, the very important phase is a code optimizer nowadays. Code optimizer phases. Today we will discuss more on the code optimization phase. So what is the purpose of the code optimization? Optimized course features. Why we are going for the optimization phase? To execute faster, so that the code size can be code size can get reduced, and efficient usage of the memory to get the better performance of the machine, to reduce the time and the space complexities. Always we will go for the code optimization phase. These are the very important features of the code optimizations. Code optimization, everybody. So to fastly execute the program, code optimization is very helpful. So optimizations are classified into the two categories: machine independent optimizations, machine dependent optimizations. Machine independent optimizations improves the target code without taking the properties of target into the consideration. Machine dependent optimization improves the target code by checking the properties of the target machine. Let us see the diagram. Our code optimization will get the inputs from the intermediate code generation phase, that is the previous preceded. The code optimization phase is preceded with the intermediate code generation. The source program is given to the intermediate code, and the code optimization phase will take the intermediate code as the input, and it gives the output to the code generator phase. So that assembly language code will be generated, that is in the target program. While doing this process, we will take the help of the symbol table data structure. Symbol table is a very important data structure. While this translation process, it always used to store the tokens and give the data to the different processing units. What are the factors to be considered for a optimization phase? So in optimization phase must preserve the meaning of the program. It cannot change the output produced by or any. After optimization phase, the program structure should be preserved. The meaning of the program should be preserved, or it cannot be changed, and it cannot introduce an error. Optimization should speed up the programs. Optimization should speed up the programs. Optimizations can be occurred different levels, in the designing levels and the compilation levels will be occurs. Improvements can be made at various phases. Source code optimizations can be there, intermediate code generations, intermediate code optimizations will be there, target code optimizations will be there. So we will see some of the techniques of the code optimizations. First comes is a constant folding. As the name suggests, this technique involves a folding of constant. For example, if you observe circumferences of the circle, there is a variable. Let us take x is equal 22/7 into diameter is there. Whenever 22/7 is found by the compiler, it immediately replaces the 3.14. This is a constant folding. It folds this constant with the 3.14 directly. This is one of the simple technique, constant folding optimization. It saves the execution time. Okay. Next technique used in the code optimization is a constant propagation. In this technique, if some variable has assigned with some constant value, then it replaces the variables with the constant value. That means, for example, we will write the instructions like hash define pi 3.14. So wherever the pi value is found, we will replace with the 3.14 value, because these are the constants, programmatical constants. Okay. So that this value 3.14 value will be propagated in the pi variable. This is a constant propagation. That means substituting the constants value during the compile time and saves the execution time. This is also one of the technique. Similarly, constant folding, constant propagation. Next technique used in the code optimization is the algebraic simplification. For example, minus of minus I replaces the positive of I. It tries to reduce the algebraic expressions. If you observe the source code here, void name of the function is f with the arguments integer I, and it contains a few instructions, 4 instructions. A of 0 is equal to I plus 0, A of 1 is equal to I into 0, A of 2 is equal to I minus 1, A of 3 is equal to 1 plus I plus 1. The compiler tries to simplify the expressions in the code optimization phase. That is the main important consideration. So if you observe, this I plus 0 is already substituted with the I only. I into 0, there is no need to evaluate. If it anything multiplied with the 0, it can reach the 0. I minus I, it is also same variable will be subtracted with the same value. It also leads to 0. So it tries to substitute the or simplifications can be done. Algebraic simplifications can be done. This is also one of the code optimization technique. Code optimization technique. So this can be substituted here, 1 plus I plus 1 can be substituted with 2 plus I. This is one of the code optimization technique. It is algebraic simplification. Next technique is a strength reduction. One of the optimization technique used in the code optimization is a strength reduction technique. As the name suggests, this technique involves reducing the strength of the expression by replacing the expensive and costly operator with the simpler and cheaper ones. As we know that multiplication operation is a bit expensive compared to the addition and subtraction operations. In floating point arithmetics, we can observe multiplication operation takes a high amount of the time. It with respect to the addition and subtraction operations. So whenever the multiplication operations are there, the compiler always tries to substitute it with the cheaper ones, that is the addition operations. Here the expression a into 2 has been replaced with the expression a plus a. A is multiplied with 2 can be substituted with the a plus a. So this is where is the multiplication operation star is replaced with the plus operation, additional operation, so that it tries to reduce some CPU clock cycles while performing the floating point arithmetic operations. So it tries to reduce the CPU time. So this is also very important code optimization technique, strength reduction. Next code optimization technique we consider is a dead code elimination or not reachable code. Dead code is nothing but the code which is not reachable, the code which is always not reachable, that is known as a dead code. Those codes are eliminated which either never executes or not reachable. So code before optimization, let us take see with an example. I assigns with the 0. If I assigns with the equalized with the 1, then is it. If you observe, I value is already assigned with the 0, but if condition is going to be checked with the I value 1. So this is never be executed, this code. This code is known as a dead code because already you are giving the value I as 0. So this if condition will never be executed because the next statement after I is equal to 0 is we have written as if I equal to assigned with the 1. So this code can be considered as a not reachable code. It never executed. This can be considered as a dead code. So it always substituted with the, this code can be substituted with the I equals 0 simply. This technique is known as a dead code eliminations. Observe, if there are hundreds of the statements are there in the if condition, 100 instructions are there in the if condition, that 100 instructions will never get executed, so that the CPU time cycles will be saved in execution process. So this is the one of the code optimization technique used by the compilers. Very important technique, dead code eliminations. So far we have observed the different code optimization techniques like constant folding, constant propagations, algebraic simplifications, strength reduction and dead code elimination. Next, common sub-expression elimination. Common sub-expression elimination. It tries to check whether any common sub-expressions are placed in the program or not, and it eliminates it. It eliminates the redundant expressions or common sub-expressions and avoids their computations. Suppose if you observe in this example, code before optimization, statement 1 is equal to 4 into I, statement 2 assigns the A of S1, statement 3 is 4 into J, statement 4 is equal to 4 into I. This common sub-expression, if you observe, 4 into 4 multiplied with the I, you can find it as a redundant expression. So 4 multiplied with I, a small unit of the expression which is repeated in our code. So it tries to save that 4 multiplied with I in a separate variable, and whenever this 4 multiplied with I is presented in our code, it automatically substitutes the S1 expression. There is no need to calculate this 4 multiplied, already we have calculated this one, S4. There is no need to calculate this 4 multiplied with the I, and there is no need to save in the one more variable S4. Already 4 multiplied with I value is already stored in the memory in the S1's variable. In the S1 variable already 4 multiplied with the I value is already stored. So there is no need to calculate 4 multiplied with the I, and again you take this variable and store it in the S2 variable. This is a redundant process. because already these are common sub expression. Here S4 it is. So whenever fold multiplier with I expression is there, immediately substitute the S1 value only. That is what we observed in our program, in this code. If you observe in this program, S5, the same statement 4 into I. There is a code before optimization, code after optimization if you observe clearly. Instead of S4, we have substituted directly S1 value only. We eliminated this expression completely so that we saved the CPU time. This is one of the technique in the code optimization. So this technique is known as a common sub-expression elimination technique. So these code optimization techniques are very useful in the compilation process. This code optimization process will help you in the compilation phase so that CPU clock cycles will be saved so that the program can be executed very faster. Thank you.